students. Dear students, so I'll be explaining MATLAB uh, uh, here. How we will be using MATLAB. So here what you can see is I have opened the MATLAB and we have few screens. Here it is the command history here, and here we have the workspace. Here we have the command window. Here it is the current folder, and here it is. If you don't have this, what you can do is you can use any default view and you'll be getting this thing. So I'll start with, say, this is MATLAB, so it is called matrix laboratory. So a equal to 1. If I enter this, it is being echoed here, and a is equal to 1. So if you open this, it is a here you see this matrix is having 1 cross 1 1 1. So unlike normal programming where you start a variable with 0, say 10 variables 0 to 9, here 10 variables are 1 to 10. So if you don't use this like this and you use it as 1 semicolon, then it doesn't echo, but it's the same thing. Or you can use b equal to 2 semicolon here. So b is equal to 2. Now you can have row matrix like a equal to 1 2 3 4 5. This is a row matrix. So you can see here a is a row matrix 1 2 3 4 5, and you can have a column matrix, say b equal to 1 semicolon 2 semicolon 3 semicolon 4 semicolon 5. So here if you open b, you have 1 2 3 4 5 column in a single column, and a is 1 2 3 4 5 in a single row. Now if you want a matrix c, which is a two-dimensional matrix, you have to write it as 1 2 3 semicolon 4 5 6 semicolon 7 8 9. So you can see here this C matrix is a two-dimensional matrix 1 2 3 4 5 6 7 8 9. So this is how the matrices are used. Anything that we do here in the command window is being stored in the workspace. So these are all temporary variables which are being stored in the command workspace. Here it is the command prompt where we are typing, and here we are getting echo if we don't put a semicolon, and not getting a echo if we put a semicolon. And in this area you can see today's date 6/11/2020 at 11:04 a.m. we are having whatever commands we are putting here, that is coming in this. So this is the command history. So you can go back to any particular date, whatever commands you have used, say 16/3/2020, or long back also you can go, say 18 to 2020, whatever matrices and commands I have used, these are listed here. So in case you want to make a script file, you can copy the commands from here and put it there. Now let's go for signal processing. I'm not discussing many other things here, directly going to signal processing. Here we are studying digital signal processing. So we will be using digital signals. So first let me clear the screen. CLC is for clearing the screen, and CLEAR is to clear the workspace. You can see now the workspace is cleared. Now say for example we need time. Only difference is that earlier you have studied that analog signal or a sinusoidal wave is 2 cos 2 into pi into frequency into time. Now here the time is a discrete time. So as the time is a discrete time, instead of t I'll be using n. So let me first define the time. Time n is equal to starting at 0, and it will go for say 1 second. But in this 1 second we need the samples. Now for the samples what we do, I put a signal 1 by sampling frequency colon 1. Now what is this 1 by fs? Fs is the sampling frequency. Now here one problem is that I have written a command 1 n equal to 0 colon means increment 1 by fs colon 1, but I have not defined what fs is. So if I put this, it will give error. What is the error? that fs is not a defined variable here. There is the function or variable fs is not there. So what I have to do, I have to give the sampling frequency. What is sampling frequency? Sampling frequency is the 1 by time period. So if my time is 0 to 1 second, I can take 100 samples in a second, I can take 1000 samples in a second. So let me consider fs to be 1000. So I'm taking 1000 samples in a second. So fs is having a value 1000. So now if I put the old command again, what I get? I get a n equal to 0 to, here the increment is up to 1001. Now why it is 1001? The reason is that we are starting with 0. Now if we take 0 to 360 degree, 360 degree and 0 are both the same things, because 360 degree is 0. So to avoid this, we have two ways. Either we take n is equal to 0 colon 1 by fs colon 1 minus 1 by fs. If I use this, then you have 1000 values. And here I had not given the thing, so it has echoed. You see, the starting is 0 and ending is 9999. And if we do it other way around, I can start with 1 by fs and have it 1. Here it also it is 1000, but the difference is that it has started with 0.0001 and ended at 1. So to have a round figure, you can take either of them, but normally we start with 0. So I use this. So n is starting with 0 and ending with 1 minus 1 minus 1 by fs. So this is my time. If I want to see the time, I can plot it. Plot n. It is a time. So you see, when I plot, use the plot command, it plots n. So the screen will come where we have a plot there. This screen comes where we have this thing. I hope what you can see here is that the plot of this plot n will give you 0 to 1 by n. So this is the n. So I close it and we go for this thing where we can have something like say signal. So signal s equal to say cos 2 into pi is 3.14 f. Now let me give a frequency of 10 hertz into discrete time n semicolon. So I have generated signal s. Now signal s is having cos 2 into pi. Now what is this pi? If I write pi, you see here 3.1416. So this is the pi that we have. It is the inbuilt value. So if I plot it, normally we do x-axis is s, sorry n, that is the time, and y-axis is the signal. So you get this sinusoidal wave. So this is a sinusoidal wave, which as it is I've written cos, so it is a cos wave. Similarly, I can do the same thing with say S1 and make it a sine and do the same thing and do a plot and S1. So you get a sine wave. If you want to compare both of them, what you can do, you can write subplot. So to make it easier, we use sub sub plot. Now this subplot you can give how many plots you need? You need two plots. So the two plots here also, it is a matrix idea. You can do 2 cross 2 or 1 cross 2. 2 cross 1 or 1 cross 2. So if I have two rows, one column, first figure, plot n s, and same thing, but the second figure n s1, you get the output as this. You see what you have? You have 0 to 1. This is the first one, which is cosine, and this is the sine. So if you want, you can put x label and y label in both of them, or you can directly write here also. And you can write down this is the cosine wave, this is the sine wave. To write a script, you open a new script and put all the commands that we did here. First with clc, clear, then sampling frequency is here, then we have n. See, I'm taking from the command history and directly placing it here, or I can replace this with this one so that I get, and after that we have s, and we have s1, two sine waves, and we can use subplot. So when I run it, it will ask me to save this file. So let me save it in a location like, say, Google Drive, my folder. Then we can have subjects, then we have DSP, we can have a new folder, DSP PROG Sino so DL try. When you run it, you change the folder here. So once you are getting this, this is the folder. Now you can put x label and y label here. X label, x label is what? Discrete time, and here also the same x label is there. You can see now. Discrete time and discrete time, and we can put a y label, amplitude, amplitude, same thing there. So you have amplitude here and discrete time here. We can put close all here, and here you can put the title. This is sine wave of 10 Hertz, and the other one will be a cosine wave of 10 Hertz. Amplitude spelling was wrong, so I run it. You have cosine wave 10 Hertz, sine wave 10 Hertz. So I'll stop here for now.